Okay, so next part of the process. We've now in code gotten the equation of the new road. That's an instance of the line structure, and it's got the correct slope and it's got the correct vertical intercept. So that matches up nicely with the algebra, which we can see here. So here is that equation that we just found in code. That's the equation right there. All right, and that represents this line on the diagram. Now we already have the equation of the existing road, which is here, and that represents this line in the diagram. And what we need to do next is look at the mathematics of how to find the point of intersection. Remember, this point here, B 4.5, that's the end of the existing road right there. What we need to find is where does this point live on the Cartesian plane. So in mathematics, how do we make that happen? Well, we have our two equations, and we write them just like this. Y equals negative 1/2 x plus 9.5, and y equals, I'll just use this version of the equation, 2x minus 10.5. Same thing, 2 over 1 is the same as 2. Okay, so we've got these two equations representing the new road and the existing road. This is the existing, and this is the new. How do we find where they meet on the Cartesian plane? Well, we use a process called substitution. We notice that we've got y, and what we're going to do is replace y in this equation here with what y is equal to in the second equation. So we're going to rewrite the first part, the right side of the first equation, and then we're going to replace y with the right side of the second equation. So now we have an equation, a single equation that only has one variable. It just has a variable x. Okay, so we can solve this equation. What we need to do is get the variable terms on one side and the constant terms on the other side. So I'm going to add 10.5 to both sides, and that'll leave me with 2x on the left side, negative 1/2 x, and then 9.5 plus 10.5 is going to make 20. And then we need to get the variable term off the right side onto the other side. So we're going to add 1/2 x to that side and add 1/2 x to this side. And so that's going to give us 2.5x on the left side. And on the right side, we're just going to have the constant 20. And of course, now what we can do is isolate x by dividing by 2.5, dividing by 2.5, and x then is going to equal 8. So we've isolated now the x value of the point of intersection for that point right here. We know that it meets at 8, and that looks like it's about accurate based on the drawing. We can sort of see that there. So we know that that point has an x value of 8, but what we don't know right now is what is the y value. So the last step is to substitute to get y. So we take either of the two equations. I'm just going to pick the second one because there's no fractions. And we substitute our x value of 8. And that gives us y equals 16 minus 10.5. And then our y value is equal to 5.5. So therefore, the point of intersection is 8 and 5.5. And just looking at our diagram up here, if we look carefully, that seems to match up too. Roughly speaking, that point is at about 5.5 on the y-axis. So now we know that that point of intersection is actually right there. So that's how you use mathematics to find the point of intersection. So in the next video, I'm going to explain how we can make this work in code.